Welcome to this sixth lecture of compiler construction. This lecture is within the context of our previous lectures that belong to syntax analysis phase of compiler, and we have learned that how to write the syntax or grammar for a language, and we also learned that how to draw parse trees for some given sequence of tokens that belong to that language. And in today's lecture we are going to start a new topic, and that is syntax directed translation. First of all, we will see that what is syntax directed translation, and then we are going to apply such kind of translation for expressions. So for this reason, first of all we will learn that what are the three types of or you can say what are the three forms of expressions, and then we will try to see the conversion of expressions from one form to another form. And after getting some basic knowledge about such kind of translation concepts, we will see the first technique for syntax directed translation, and that technique is syntax directed definition. So first of all we will see that what is syntax directed definition, and then we try to apply this technique for infix form of expression to postfix form of expressions. And within this technique, first of all we will see that how to write syntax directed definition, and then how to draw annotated parse trees for some sequence of tokens that belongs to input, and how to transform that input to output with the help of annotated parse tree. And within that context we also see that what are the meaning of synthesized attributes within the annotated parse tree. So let's start by seeing that what is the syntax directed translation. So syntax directed translation is in fact a translation mechanism in which we use the grammar, or you can say the syntax of a language, to transform some tokens string that belongs to that language into some output token string. For example, considering the our previous example of expressions, in which we had learned such kind of infix expressions like 9 plus 5, and we will see that in later slides we will see that how to transform such kind of infix expressions into pre or postfix forms. So we will use syntax directed translation for this purpose. For example, if the infix expression is 9 plus 5, then its postfix form is 9 5 plus. Or if we apply syntax directed translation for translating such infix expression to prefix form, then against this 9 plus 5, the prefix form expression, that is plus 9 5, will be the output for such syntax directed translation. So first of all we will see that what is the infix expression. So let's say the e is a variable or some constant simply. For example, the expression is just 3, or you can say the expression is just b. Then it can also be said as this is the some form of expression, because the expression can be such in a such simpler form. So the second rule about infix form of expression notations says that the infix form of expressions having multiple operands should be in such form that those operands are surrounding the operator. For example, 3 plus 5 is infix form of expression because 3 and 5 are operands, and they are surrounding plus, that is operator. Okay, and infix form of expression can be within parentheses. For example, 3 plus 5 within parentheses can also be written for infix form of expressions. So now we will see that how to convert such infix form of expressions to postfix forms. So for example, E is representing the infix form of expression, and E prime is going to represent the corresponding postfix form expression. Then the first rule for such kind of conversion says that if infix form of expression is in a simplest form, means it's just constant or just variable, then its postfix form will be equal to its infix form. For example, if infix form expression means E is equal to just 3, then E prime is equal to 3. Similarly, if E is equal to B, then E prime is equal to B. The second rule says that if infix form expression means E is in such a form that E1 operator E2, for example in a form 3 plus 5, okay, then its corresponding postfix form will be the postfix form of the first expression, and then postfix form of the second expression, and at the end the operator will come. So it means for 3 plus 5 the postfix form can be obtained by first of all obtaining the postfix form for 3, and by rule number 1 we can say that if 3 is a sub expression, then its postfix form is 3. Okay, so we are going to write 3 for as a postfix form for this first operand, that is 3, and then we are going to write 5 as a postfix form of this second operand 5, and then operator will come. So it means that 3 plus 5 postfix form becomes 3 5 plus. And the third rule says that if the infix form expression is in such a form that some sub expression is surrounded by parenthesis, then the postfix form of that expression is equal to the postfix form of sub expression. Means, for example, if the expression is 3 plus 5 within parenthesis, then its postfix form is equal to 3 5 plus. Similar kind of rules apply to for conversion of infix to prefix form of expressions. So considering again E as an infix form of expression and its corresponding prefix form expressions are represented by E prime, then the first rule is the same. Means if the expression infix form expression is in a simplest form, that is it's just a constant or it's just a variable, then its prefix form is equivalent to this infix form. Okay, the second rule represents that if infix form expression is in such a form that first sub expression, then operator, and then second sub expression, then its postfix form is equal to first the operator will come because it's prefix form, and then the prefix form of the first sub expression, and then the prefix form of the second sub expression. So a simple example says that if its infix form expression is just 3 plus 5, then it means this prefix form can be achieved by placing this operator in start, means plus, and then the prefix form of 3, and that is by rule number 1 just 3, and then the prefix form of 5, that is just 5. So accumulatively this becomes E prime is equal to 3 plus 3 5. Okay, and similarly if infix form expression is in such a form that a sub expression is surrounded by some parenthesis, then its prefix form expression is equal to the prefix form of the sub expression. So it means that if the expression is 3 plus 5 within parentheses, then its prefix form expression is equal to plus 3 5. So it means if the expression is just the infix expression is just 3 plus 5, then its prefix form is plus 3 5. And similarly, if this expression is surrounded by some parentheses, then again it doesn't matter that it doesn't matter on the prefix, its prefix form. So the prefix form is again same, and that is just plus 3 5. Okay, so here we see some another examples for infix to pre or infix to postfix of conversion. So for example, here the expression is in such a form that it has a sub expression 3 plus 5 within parentheses. It has another sub expression, and that is 4, and infix form expression is in a form that e is equal to first sub expression, then operator, that is minus, and then second sub expression. Okay, so the rule number 2 says that operator will come first, and then there should be the prefix form of this first expression. Means if we name this first expression as e1, then prefix form is e1 prime, and then the prefix form of second expression means e2 prime. Okay, so it means for 3 plus 5 parentheses within parentheses, its prefix form is plus 3 5. And similarly, if we see this e2 sub expression, that is just 4, then this prefix form is also 4. Okay, so as a whole, the prefix form of this whole expression will become as minus, because minus is the main operator within these two sub expressions. And then the prefix form of first sub expression, and that is plus 3 5, and then the prefix form of second sub expression, and that is just 4. So it will become minus plus 3 5 4. Okay, now we see another example to convert infix form expression to postfix form expression. Okay, if again we take such kind of example that infix form expression is in a form that there is first sub expression, that is 3 plus 5 within parentheses, and then an operator minus, and then second sub expression, and that is 4. Okay, so if we just denote this as first sub expression by e1 and denote this second sub expression by e2, then as a whole expressions, postfix form will become as the first expressions postfix form, then second expressions postfix form, and then operator. Okay, and as you know, or you can say as we have learned in earlier slides, that the postfix form for 3 plus 5 within parentheses will be 3 5 plus. Okay, so first expressions postfix form, that is 3 5 plus, will comes first, and then after that second expressions postfix form, that is just 4, will come next, and then the operator will come. So it means the for this mains infix form expression, the postfix form will become as 3 5 plus 4 minus. Okay, so it we got the basic concepts, that what is syntax directed translation. We also learned that what are the 3 type of forms of expressions, that is infix, pre, and postfix forms. And we also learned that how to convert infix to prefix or infix to postfix forms. Now we are going to learn the first technique for syntax directed translation, and this first technique is syntax directed definition. Syntax directed definition is in fact a 2-column approach in which the syntactic structure of the input, or you can say the grammar of the input, is written within the first column, and within the second column a set of semantic rules are given against each production, and these rules define that how to translate from input to output. And there are also a set of attributes that are associated with the grammar symbol, and in fact these attributes show the or you can say the define the output, and in order to evaluate the output, or you can say the attribute values of these attributes are computed with the help of semantic rules that are given within the second column of syntax directed definition. Okay, so for example, if we want to convert the infix form of expressions into postfix form, then its syntax directed definition is given here. You can see here there are two columns. Within the first column means this one, the grammar is given of infix form expressions, because infix form expressions are our input. So the syntactic structure of input means the syntactic structure of infix form expressions is given here, means the grammar of infix form of expressions is given here. Okay, so it's just the grammar we already learned, that is, the expression can have the form of expression plus digit, or expression can have the form of expression minus digit, or expression can have the form of digit, where digit can have the form of 0 to 9. Okay, here 1 is written as a subscript of this expression in order to just differentiate that this one means without subscript is the main expression and with subscript is the sub expression. So it's just for sake of differentiation, otherwise it's the production is expression can have the form of expression plus digit. Okay, now if you see the second column, then you see that there is a set of attributes that are associated with each production. For example, consider this first production, expression can have the form of expression plus digit. Here only one rule is given, so in this case only one rule is required, because we have to evaluate the postfix form, and because postfix form is just one thing, so we just have to give through semantic rules that how to evaluate the postfix form for a particular infix form. Okay, so for this infix form of expression, means expression can have the form of expression plus digit, as we have learned in the rules that its postfix form will be the postfix form of the of this sub expression, and then postfix form of this digit, and then the operator will come. So the semantic rule is giving this information. It's saying that the postfix form of this main expression. Okay, so here it is written exp.t. Here t, which is actually a small letter, is just showing the attribute for translation, and here that by translation we mean that the postfix form. So it means that t is representing the postfix form. So if t is going to associate, means this attribute t is going to associate with this grammar symbol exp, that is, we are going to write exp.t, so it means it is showing that the postfix form of this expression. Okay, and here exp1, here exp1 means the sub expression. exp1.t is showing the postfix form of this sub expression. Okay, the semantic rule is saying that the when the expression can have the form of expression plus digit, then this main expression's postfix form is equal to this sub expression's postfix form concatenated with, this sign is showing concatenation. So concatenated with the postfix form of this digit means digit.t, and then the operator will come. Okay, and similarly the second rule is saying when expression can have the form of expression minus digit, then the main expression's postfix form is equal to the sub expression's postfix form concatenated with the digits postfix form, and then minus will come. Similarly, when expression can have the form of digit, then its postfix form is equal to the postfix form of digit. Okay, and when digit can have the form of 0, then simply it means that its postfix form will also be 0, as we have learned earlier. So and so on. When digit can have the form of 1, then its postfix form is 1, and so on. When digit can have the form of 9, then its postfix form is equal to 9. Okay, so we have seen that for this particular kind of translation, means from infix to postfix, we have used this two-column approach for syntax directed definition, and in this first column the syntactic structure of the input is given, and within this second column the semantic rules are given, which are actually showing that how to compute input to output. Okay, so we already learned that here T means some attribute that is associated with a grammar symbol, and for example here digit dot T, so the grammar symbol is digit and T is attribute associated with digit, and it is showing the postfix form of this digit. Okay, now we are going to apply this syntax directed definition to get an output against an input. So for example, consider this infix form expression 2 minus 3 plus 5, and we want to compute its output using syntax directed definition. Then as we have learned earlier that this is the syntax directed definition for such kind of translation mechanism. And first of all, in order to compute output, means the postfix form for this infix form expression, first of all we will draw the simple parse tree for these sequence of tokens. Okay, so using this grammar we can draw this parse tree. So this expression consists of two sub expressions. Mainly this expression is of a plus expression, and the first operand is a sub expression, that is 2 minus 3, and the second operand is a digit. Okay, so applying this first production for the main expression, means for plus operator, we choose this production, that is expression can have the form of expression plus digit, where the sub expression means this 2 minus 3 can be obtained by this exp by using this production, means exp can have the form of exp minus digit, where exp can have the form of digit and digit can have the form of 2. Okay, so 2 minus, and then digit can have the form of 3, so 2 minus 3 is produced here. So it means the first expression is here, the first sub expression is here, and then the second operand is just a digit, and that digit is 5. Okay, so as a whole this expression will become 2 minus 3 plus 5. So first of all we will just draw the parse tree for given input, okay, using a first column, means the grammar. Then the second step is, at each grammar symbol we are going to write the corresponding attributes which is given within the semantic rules of the second column. Okay, so as we have learned earlier that here the semantic rule is showing the postfix form, and we are going to represent the postfix form through an attribute T. So it means in order to evaluate T for this expression, which is the main expression, and that's the ultimate goal of applying this syntax directed definition. So in order to achieve this ultimate goal, we first have to evaluate the values for its child nodes. Okay, so starting from its left operand, means this expression's main expression's left operand, means this one. We want to evaluate the value for this expression's postfix form, but in order to evaluate it we again have to go to its leftmost child, then rightmost child, then we will come to evaluate it. So when we go to this leftmost child, then here expression can have the form of digit. So this expressions postfix form still cannot be evaluated using these semantic rules. In order to evaluate it, we have to evaluate its child's attribute first, and its child is this digit. So digit dot t can be evaluated directly from this semantic rules, because semantic rules are saying when digit can have the form of 2, then digit's postfix form will be 2. Okay, so digit postfix form will be 2. And now when we have evaluated the postfix form for this digit, then it means we can evaluate the postfix form for its parent. Means expression dot t is equal to 2. How this postfix form comes? Because here syntax directed definition is showing when expression can have the form of digit, means when this production is going to be applied here within this parse tree, means when expression can have the form of digit, then semantic rules are saying that expression's postfix form will be equal to the digit's postfix form. And as we already evaluated digit's postfix form, that is 2, so it means the expression's postfix form will also be equal to 2. Okay, so the left child of this expression is already evaluated, and now we have to evaluate its right child so that we can evaluate this t. Okay, so in order to evaluate this right child, we again see the syntax directed definition. Here production is used, digit can have the form of 3, and its corresponding semantic rule is saying that digit dot t will also be equal to 3. And similarly, here production is used for in order to compute this expressions postfix form. We just see that what production is going to be used here. The production is used here, expression can have the form of expression minus digit. Expression can have the form of expression minus digit, and here semantic rules are saying that this main expressions postfix form will be equal to the sub expressions postfix form, means this 2, and then digits postfix form means this 3, and then the minus will come. So it means this expressions postfix form will be equal to 2 3 minus. Okay, and then in order to evaluate this main expressions postfix form, we already evaluated its left child, and now we are going to evaluate its right child's attribute, and right child is digit, and here digit can have the form of 5 is used, so it means digit dot t is equal to 5. Okay, so now we can evaluate this main expressions postfix form, which is the ultimate goal. Okay, so here production is used, expression plus digit. So we will see the syntax directed definition, and it is saying when expression can have the form of expression plus digit, then this main expressions postfix form is equal to the sub expressions postfix form. So this main expressions postfix form is equal to the sub expressions postfix form, means 2 3 minus, then digits postfix form means 5, and then plus. Okay, so 2 3 minus 5 plus will be the main expressions postfix form. Okay, so our answer is the postfix expression for this infix expression is 2 3 minus 5 plus. Okay, now you can see attributes are associated with each grammar symbol, and here some attributes are going to be evaluated directly by seeing syntax directed definition. For example, when we have to evaluate digit dot t, then it can be directly seen from syntax directed definition that digit when digit can have the form of 2, then digit dot t is equal to 2. And similarly, when digit can have the form of 3, then digit dot t is equal to 3. When digit can have the form of 5, then digit dot t is equal to 5. But in order to evaluate such attributes, we have to evaluate their children first. Okay, so such attributes which cannot be evaluated directly from syntax directed definition, rather we have to evaluate their children first, and then we can evaluate those attributes. So those attributes are called synthesized attributes. Okay, and overall this tree is called annotated parse tree. Okay, so as you can see that this is not a simple parse tree, because in simple parse tree there are not attributes and their values are not shown in that tree, whereas in annotated parse tree the attributes of grammar symbols are also shown along with their values, and the value of the root node is our required output. Okay, so here you can judge this t, and this t, these attributes are synthesized attributes because their values cannot be computed unless you compute the values of their children. Okay, so this is the concept of applying syntax directed definition in order to get some output from an input. Secondly, we see that how this process is going to be accomplished. It is going to be accomplished with the help of some annotated with the help of drawing some annotated parse tree. And in order to draw that annotated parse tree, firstly we have to draw the simple parse tree, and then gradually we are going to compute the values of its attributes, and finally when it is going to be completed, and we can say that it is annotated parse tree, and within this parse tree those attributes whose values cannot be computed unless the values of their children are computed, then those attributes are called synthesized attributes. Okay, so this is the concept of our first technique of syntax directed translation, and that is syntax directed definition. Thank you.